Check, check. All right. Get going here in just a second here. All right, you all ready? Let me the projector's pretty bright. I'm gonna do record this like a session, and I'll upload this so it'll be the screen capture. I wanted to do it like this today because we're going to look at some graphs of things. I just thought it'd be faster if we just do it that way. So I'm recording and just make sure everything's good here. Yep. Okay, this should be good. All right. So how about those problems I sent out? Any issues with those at all? The logarithmic equations? Sorry, I didn't send them out on Tuesday. I sent them out yesterday morning. So any issues? 8? Yeah, I was hoping, I was guessing you would ask about 8. Let's do it. So what was 8? Like, remind me. Well, you know, I think I have it right here. This one right here. Yeah. Okay. I was curious how you would go about this one. So is that big enough? Do I need to go bigger? Is that all right? Yes. Okay. So first of all, you try and isolate the log, right? Which it is isolated. And so all we need to do here is the loop, right? So you do your little loop, 2 raised to the 3rd equals this. So 2 cubed equals x squared minus 2x, right? And then you go 2 cubed, that's 8. So 8 equals x squared minus 2x. And now this is the first time we've had a quadratic equation. It's not linear, right? So you have to solve it like a quadratic. So move everything over to one side. So I will subtract 8 on both sides, let's say. So we get 0 equals x squared minus 2x minus 8, that. And then from there, we can either factor or you can use the quadratic formula. It's totally up to you. Factor, is that okay if I factor? So that would be where you do that thing where you take the number in front, multiply by the back, -8. You're trying to find 2 numbers that multiply to be this, but add up to be the number in the middle. So those 2 numbers are -4 and +2. So you'll put x minus 4, x plus 2. And now you set each of those factors equal to 0. So x minus 4 equals 0, and x plus 2 equals 0. And you get 2 solutions, 4 and -2. That all makes sense? The only difference between this problem and all the ones before is that at the end you wound up with a quadratic equation as opposed to a linear equation. So I was just curious how you would handle that. Just to show you, in my other college algebra class, we're doing logarithmic equations as well. Let me show you, wait a minute. Why is that not? I'll have to show you in a minute. It's updating. It's updating off the cloud right now. So what we are not going to do, and I didn't mention this to you all, because again, we're kind of going kind of the not aggressive way through this class, and that is we actually are supposed to check our answers. Whenever you're dealing with logarithmic equations, you always have to check every problem I've given you up to this point. The answers are actually going to work. This problem here, the doesn't work. Or, no, they both work, but we're supposed to check our answers. So I just want to say that to be on the record. Anytime you solve a log equation, you should check your solutions. But that's it for -2. Any other questions? Yes. 3. I'm gonna make this a little bit bigger. There. Okay, so we're trying to solve this log equation. We have to get the log by itself. Right now, the log, this is the part with the log, right? So we need that by itself. We need to get rid of that +6. So subtract 6 on both sides, right? So I'll just subtract 6 there. Have you gotten that part? Yes, okay. And go ahead. You figured it out now?
And that's supposed to be a 10.
Yes. Okay. So if the base is not there, it's a 10. So it's not written here, but we have to understand that there is a 10 down here. It's one of those special logs. And then we do the 10 raised to that equals this. I'll go ahead and just finish this off. 10 squared equals -4x plus 1. 10 squared, of course, is 100. Subtract 1 from both sides. If you do that, you get 99 equals -4x. And then divide both sides by -4. And we'll just leave it as a fraction as an answer. We could get on our calculator and do a decimal, but that's fine just to leave it like that. Okay, so if you did it, I told you to have it ready to turn in. Again, do that picture thing so that you have a copy of it, and just go ahead and get those ready. Make sure your name's on it. While you're doing that, I'll see it. For some reason, it's not loading. What the heck? Oh, you know what? It's here. There it is. Yeah, so this is my other college algebra class. And these are the logarithmic equations that they do all the odd problems from here. So everything that we're doing in this class is pretty much problems like 1 through 5 through 8. So like those we could handle in here. And then they start getting much more complicated. You have multiple logarithms within the same equation. It gets pretty intense. So we're not doing that. It's a good thing, I guess. Okay, you'll have those ready? Ready for Easter? Tomorrow's a holiday, right? All right, so today we are shifting gears. We're going to do something completely different today, which is why I brought this setup so I could make it a little easier for myself to do this. Today, we are going to do problems. I'm not going to tell you yet what we're going to do. I'm going to give you a problem to kind of get you to think about the idea. All right. So let's say, trying to consider, there's so many different examples. Let's do a problem that I'm going to put up here. Right now, we will not be able to do this problem. Okay. And then by the end of today, we will be able to do it. All right. So you wish to mix a 5%. I'll make this bigger. Let me make it bigger so you can see it. Acid solution with a 30% acid solution to get 2 gallons of 20% acid solution. How much of each should you mix? Question mark. So I'm going to draw you a picture to kind of give you an idea. This is done in like in chemistry classes and chemistry labs. What you'll do is you're gonna need to run an experiment, and maybe you need in that experiment you need a 20% acid solution, which means you've got basically like pure water mixed with some sort of acid. I don't know, it can be different types of acid, but we'll just say generic acid here. You need that 20% acid solution for the experiment. But in the storeroom where they keep all the chemicals, all they have in the back is a 5% acid solution and a 30% acid solution. So they have one that's pretty weak, 5%, and then a really strong acid solution, 30%. And so what you need to do is you need to mix those two together so that you can get 2 gallons of 20%. Make sense? And the question is, how much of each do you pour in so that when you're done, you have exactly 2 gallons and it's 20%. So in a picture, we would have, this right here would be the container that has the 5% in it. We're gonna mix it together with this other container that has the 30%, right? And at the end of it, what we want, is a 20% mixture, but exactly 2 gallons, right? So we want to know how much of each of those two do we pour in together. Does that make sense to you? Any idea of how the hell we do that? It looks pretty complicated, right? So we will be able to do that by the end of today. All right. It seems really hard, but it's actually the math behind it's not going to be too tough. All right. Okay. So that's the goal for today, is to be able to do that problem at the end. So let's get started. Today, what we are doing is something called solving systems of linear equations. Okay, that's what today is about. So let me remind you of what just a linear equation is. You've looked at these before. Linear equations look like this. We'll go very basic to start. X plus y equals 10. That is an example of a linear equation. It has 2 variables in it, x and y. And we could sit here right now and think about all the different x's and y's that would make this equation true. So can somebody give me an example of an x and a y that would be a solution to that equation? Any x and any y that you can think of that would make that statement true. 2 and 8, okay? I could do 2 and 8, right? And then another one, 1 and 9, okay? Could I flip that around in this problem? Could I do 9 and 1 for this problem? I could have, right? 1 and 9 would have worked. I'm sorry, 9 and 1 would have worked. Any negative numbers? Can we do a negative? Like, could I do x is -2? What would y have to be? 12, right? So we're doing this just by inspection, just by looking, right? Just by looking. But now remember, we actually know that linear equations, if you solve them for y, right? Let's get y by itself. That means that I would subtract x on both sides of this equation. Wouldn't I get minus x plus 10? So I took x away on the left and I subtracted x on this side, which left me 10 minus x, but I wrote it as negative x plus 10. Does that look familiar? If I asked you to graph this, what is this? What is that? Press it or graph it. Y equals mx plus b. Does that look familiar? This is a line, isn't it? This is a line. And the slope of that line is the number in front of x. So the slope of this line would be -1. So let me just real quickly remind you how I'd graph that if I needed to. I would draw a grid. Let me cheat here. So here's my grid. I would draw an x and a y axis like this. Right? And I could use this right here. My y-intercept is 10, right? That's where I hit the y-axis. So let's count by twos. 2, 4, 6, 8, 10. I would hit here at 10. And then another point on my graph, I would go down 1, right? The slope means down 1 over 1, rise over run. So if I went down 1 over 1, I would get this line right here. I'm going quickly through this because we've been through this before. Does that ring a bell? How we do that? Solve for y, y-intercept, slope. Okay. So look at these points. See this point 2, 8? That point is actually on this line, isn't it? 2, 8. That right there is actually that point right there, isn't it? And what about the next one? Let's do 9, 1. How about that one? That one, you go out to the right 9 and up 1. It's right there. That's 9, 1. So remember, the whole point is when you have a linear equation can be graphed as a line, and the line really represents all the different solutions, right? Just drawn out on a solid line. So what we're doing today is we are solving what is called a system of linear equations. So it's not this, it's something related to this, but it's not exactly this. So now I'm going to give you something else to think about. So what if I give you this equation, x plus y equals 10, that's the one we just had, right? Okay, so this is kind of a separate idea. And now I give you another equation, x minus y equals 10. These are not the same equations, right? So can anybody right now think of an x and a y that solves this equation and this equation simultaneously? In other words, can you think of an x and a y that works for both? Take a minute to look at it. Think of, I mean, we already looked at some for here, right? We said like 2 and 8, 9 and 1. You know, we know there's a bunch of solutions here. This is a different equation. We could find a bunch of solutions here, but is there an answer? Is there an x and a y that works for both? 10 and 0? What do y'all think? If x is 10 and y is 0, right? Does that work in both of them? Try it here. 10 plus 0 is 10. Yes, I agree. How about over here? 10 minus 0 is 10. It works, right? Do you think that there are any others? So think about it geometrically. If I graph this, right, all the solutions, what do I get if I graph that? A line, right? And we just graphed it, right? And it looked like this. And if I graph this one, right, it's going to be some other line, right? It's not that same line because they're not the same equations, but it'll be some other line, yeah? I'm not sure what it'll look like. We'd have to go through and graph it, but let's just imagine we have another line here. What do you think this point 10, 0 is? Graphically, what do you think it represents? Where those two lines would hit each other. If I were to graph both these lines together, the point where the two lines would hit would be the point that is a common solution to both equations, right? Because the line represents all the solutions to that equation. So where the two lines would hit would be a point that's a solution to both. Does that make any sense? So let me graph these using my computer. If I do x plus y equals 10, equals 10. There's the graph of x plus y equals 10. And then if I do x minus y equals 10, there's the other line. And do y'all see where they hit each other? What's that point right there? 10, 0, right? Which is the point you came up with. That's the only point though. There is no other x and y that you could ever come up with that would be a solution to both simultaneously. So what our goal is now is this. I give you two linear equations and you find the solution that is a solution to both at the same time. That's what the solution to a system of linear equations is. All right? Does it make sense? How to do it, I haven't shown you. How we do it, just wait. But that's the actual goal. So how do I do this? How do I let you know this is what I want you to do? So a solution, I'm just writing out, just kind of recapping, a solution to a system of, why is that doing that? Linear equations is a point which is the intersection of both lines. So that's what we're looking for, the solution to a system of linear equations. So let's do our first example. And what we're going to do is we're going to do the one we just looked at, the one that we already know the answer to. The answer was 10, 0. But how do I let you know I want you to solve a system? Here's how I do it. I write the first equation, x plus y equals 10. And then below it, I write the second equation, x minus y equals 10. And then in front of it, I put a big curly brace like that. Y'all seen that symbol before, yes? A curly brace. When I put the curly brace in front of the two equations like that, that is letting you know that I would like for you now to find the x and y that make both of those true at the same time. All right. Now, there are a set of steps to do this, but the steps are, if I write them out, they're going to look weird. All right. I will try to in a minute, but let's go through the process first. And then after we do one or two of them, I'll write the steps out. So the technique to solve this, right? To solve this, we have two options. In other words, there are two techniques. There are two things that I can teach you on how to solve a system of equations. And the first one is called substitution. And the second one is called elimination. Now, remember last class I was telling you about that kid, Gauss, right? And Gaussian elimination. Elimination is the method that he came up with, right? That's named after him. I will tell you right now that for this class, okay, for this class, when you have two equations, right? We have two equations here and we have two variables, x and y. Substitution is enough. That's all you need. You don't need elimination. But later on in math, not in this class, but in other math classes, sometimes you get a system of equations where you have three equations and three unknowns, like x, y, and z. Or you could have four equations and four unknowns, or 5 and 5 unknowns. And when you get to that point, elimination is more powerful than substitution. So for us, substitution will be enough. I will show you elimination because sometimes elimination is the easier way to do the problem. Like for this problem, elimination is the way I would go. But I'm going to show you substitution first. All right. So here we go. You ready? We're going to do substitution. So the way substitution is going to work is that you're going to look at both equations, all right? You got the first one, the second one. And you get to choose right now which equation you want to work with. And you're going to take the equation and you're going to solve it for y. Okay, so I'm going to choose to take the first equation and I'm going to solve it for y. What do I mean by solve for y? I just mean get y by itself on one side of the equation, all right? So there's my equation. I'm going to subtract x on both sides. It doesn't matter how you write this. When I subtract x on both sides, I can have 10 minus x, or I could have written it the way I did earlier, which was negative x plus 10. Your choice. Okay, have I solved for y on the first equation? Yes, right? Okay, that first step's done. Okay, so that was my first step. I picked an equation, pick an equation, solve for y. Okay, that's what I've done. That was kind of like the first step. The second step is to take the other equation, okay, which is this one, write it down, x minus y equals 10. And what we're going to do is we're going to take what we just got. What did we say y was equal to? Y is equal to 10 minus x, right? That's what we just said. Y has to be 10 minus x. We're going to use the other equation and we are going to replace this y right here in that equation. We're going to replace it with this. In other words, we are going to substitute that y out for this. That's what I would call a substitution. We're going to substitute that in here for this. So let me write that down. I will have x minus, now be real careful here. When I replace this y with 10 minus x, this negative sign is still in front, which means I need a parenthesis around the 10 minus x. That way the negative sign will distribute through and then equals 10. Any questions on that? This y got replaced with the thing in green. Now look at this equation. This is a linear equation, but you only have one variable in here now. You see that? There's only an x. So I'm going to now solve this. So let's say this step right here, what did we do? We substitute y into the other equation, right? The other equation, that's what we did. So the last step would be, sorry, not the last step, second to last step. The next thing we're going to do is we're going to take this where we were there, we're going to solve for x. So take this thing that we have right now. Distribute the negative through. X minus 10, what is that? Plus x again equals 10. So distributed my negative through. Let's collect like terms. I have an x plus an x, so I have two x's on the left side. Minus 10 equals 10. We'll add 10 to both sides. We get 2x equals 20. And then what would be my last step after I do that? Divide both sides by 2. Good. So x is what? 10. And that's what we said earlier, right? We said x would be 10 and y would be 0. Well, how do we get y is 0? Right now we know x is 10, right? So now is the very last step. That's not the last step. We know what x is, right? We know what x is. So let's go back and look up at our work. Did we ever solve for y? Yeah, we solved for y right here, right? So if I know what x is, then now I can find y because I have an equation that has y solved for. So this will be my last step. I'm going to substitute the answer we just got for x into the equation we have for y. Sorry, that looks terrible. So I'm referring to this equation right here. That's the equation we have for y, right? I'm going to take that in over here. Y equals 10 minus x. And I will replace x with 10, right? Because we said x was 10 down here. We said x was 10. So replace that x with 10, 10 minus 10, well, then y is 0. And now I know what x and y are. Now you got to just by looking, right? But that's because the equations were easy. If the equations get harder, you have to have a method. So this is the method. All right. Do I need to leave that up there or go back? No. All right, next example. Solve this system. Let's go with 3x minus y equals 12, negative 4x plus 2y equals 7. All right. Nobody is going to get this by just looking. Well, I don't think anyone's going to get this by just looking. Yeah. Can you tell me an x and a y that work for both at the same time? I don't think so, right? I mean, you could give me an answer for maybe the first one. You could tell me like 4 and 0 would work for the first one, right? But 4 and 0 is not going to work here. So we're trying to figure out what works for both. Now, what do you think? Does there have to be a solution? Think about it geometrically. You have two lines, right? The solution is where they hit each other. Do two lines have to hit one another? No, they could be what? They could be parallel lines, couldn't they? In which case we'd have no solution. So it is possible to get no solution. And you could actually have the same line. Like both lines are identical, so they have the same slope. So that means they hit everywhere. Those are extreme cases. I'm not going to give you any of those. But that is something we would have to think about big picture if we were interested in that. We're not in this class. So, all right, here we go. Let's just follow the method, okay? Look at the two equations, pick one of them and solve for y. So would you rather take the first equation and get this y by itself? Or would you rather take the second equation and get the y by itself? First one, okay, let's do that then. Let's take that first equation. Right, I think the reason I agree with that is because on the second equation, if we solve for y here, we're gonna have to divide by 2, which means we're gonna create fractions. And we're just like, let's try and stay away from fractions as long as we can. So I'm gonna take my first equation and solve for y. That means you need y by itself on one side of the equation. How would you like to do that? There's multiple ways to do this. You could move the 3x over and then get rid of the negative in front of the y, or you could move the y to the right and move the 12 to the left. It's totally up to you. So what makes more sense to you? Do what? You want to do minus 3x? That's fine with me. Everyone okay with that? Let's do minus 3x on the left, minus 3x on the right. On the left, you go away, or it goes away. You get negative y. Don't forget, you still have the negative y. Equals, and then on the right, you cannot combine those together, right? You can't combine these together. 12 minus 3x is 12 minus 3x. You still have negative y here. Are we good? Now I need y, not negative y. So how can I get rid of the negative 1? How do you mean push it? So yeah, this is a negative 1 being multiplied, right? So we would have to either multiply both sides by negative 1 or divide both sides by negative 1. It's your choice. So let's go with divide. Divide by negative 1, divide by negative 1 here. You divide each of these by negative 1. And let's just see what the effect that this has is that it changes the signs of everything. So on the left side, you have y. On the right side, you'll have negative 12. and you'll have plus 3x. Okay, so everything that used to be negative is positive, and everything that used to be positive is negative. We good? That's the first step, right? We look back at the previous problem. The first step was to pick an equation, which we did, and we solve for y. Got it. Okay, we have solved for y. Now, we're going to substitute y into the other equation. So that means I'm going to write down the other equation. The other equation was this one. Negative 4x plus 2y equals 7. Negative 4x plus 2y equals 7. And I'm going to replace the y with negative 12 plus 3x. What are you going to do with that 2 that's in front of the y? You're going to have to distribute it, right? So you need to put that y in parentheses, negative 12 plus 3x, and then equals 7. Any questions there? Distribute the 2 through. Wait, hold on. Let me go. I think this is my second step, right? That's my second step. We've completed that. We've plugged it in, right? Now, the next step would be solve that equation for x. Okay, so we're going to take where we are, we're going to solve it for x. So my next step is to take this equation, solve for x. I'll distribute that 2 through. And this gives me this, right? Distribute the 2 through here. And then collect like terms. I have a negative 4x and a positive 6x. That should leave me with a 2x minus 24 equals 7. We got to get that x term by itself. So let's add 24 to both sides. So 7 plus 24, right, is 31. And then finally divide by 2. 31 over 2. I know what x is, right? Okay, I hear the calculator. Good. We could get this as a decimal if we want. 15.5. Oops. Right? 15 and a half. Questions? That's our third step. Our last step is we've got to take this answer for x, right? And plug it into that equation we have up here for y. So we can figure out what y is. So let's do that. I'll do that over here on the side. So my last step here is to take this equation, y equals negative 12x plus 3x, sorry, and replace the x with, well, let's do the decimal, okay? Instead of plugging 31 over 2 in, let's plug in 15.5 for that x. So 3 times 15.5. We're going to get a decimal here. Negative 12 plus, what is that, 46 and a half? 46 and a half. And then y equals, take 12 away from that, 34 and a half. 34 and a half. What do y'all think? Do you have any questions on that? What I'm going to do while you're kind of finishing that off, I'm going to graph this. Negative 4x plus y, oops, yeah, equals 7. That was one of the equations, and the other one was 3x minus y equals 12. Okay, so just to show you again what we've done, this is the graph of both those lines. Okay, when I graph it on the computer, and if I zoom out, you can see that they hit each other right here. So let me make this a little easier to look at. right there. Where those two lines hit each other, 15.5, 34.5. That's what we got, right? So yeah, there's no way that in the beginning of this problem, right, when I said, hey, tell me what X and Y make this true, no one's going to say 15.5 and 44.5. It's just not going to happen. 34. All right. So you ready to see elimination? The other method? We'll do elimination on these. We're going to do the same two problems, but we're going to do them with elimination. All right. So let's go and now talk about elimination. Everything that we've done so far was substitution. So elimination, we're going to take that first one, x plus y equals 10, and the other one was x minus y equals 10. And we know that the answer here was 10 for x and 0 for y, right? So elimination is completely different. I mean, you don't do those same steps, all right? So here's what you do. Let me explain it. Make sure that first you have your x's first, then your y's, then your equal, then your numbers. You got to have everything in the correct order. X's first, then the y's, then the equal, then the number, which we have. And now what you do is you look at the x's, you ask yourself, if I added these together, would they go away? So if I did x plus x, I would get 2x, right? They don't go away. But if I add the y's together, y minus y, that would go away, wouldn't it? And that's what you're looking for, is seeing whether or not when you add down one of the variables will go away. So I noticed that now, right? If I add down, so what you're going to do is you're actually going to just add these down. Okay, so look at it this way. You're going to add these down, okay? Meaning you do the x plus the x, that's 2x, right? And then these two added down, that gives you plus nothing, right? Because y, take away y would be gone. And then equals, and now you add these two down, and 10 plus 10 is 20. And so you don't need that 0 there. This is just saying 2x equals 20. Do you remember we got that same result when we did substitution? We actually got to that point. If you go back and look at the problem we did, when we did substitution on this, we did all this stuff, solve for y. Then once we did that, we replaced that in here in the second equation. Once we've solved for x, we finally got to a point where we said 2x was equal to 20. And then we got x is 10. See, we just got that almost immediately, right? The same result. So now divide both sides by 10, by 2, and you get 10. So already we have x, just almost instantaneously. Now, how do we get y? To get y, what you can do is you pick either one of these equations. It does not matter which one. Pick either one and just plug x equals 10 into it. So I'm going to choose to just take that first equation, and I'm going to write it down first, x plus y equals 10. And I'm just going to replace the x with 10. And I get 10 plus y equals 10. And subtract 10 on both sides, and you should get y is 0. Boom, we're done. That was easier, wasn't it, than substitution? For that problem it was, okay? Can I move on, or we're gonna do the second example now? So the second problem we had was this one. And I'd like to try elimination here. All right, so I look at this, right? I'm looking at this and I'm like, okay, let's look at the x's first. If I add the x's down, do they go away? 3x, take away 4x, that would be negative x, wouldn't it? That doesn't go away. And then I look at the y's, negative y and 2y, if I add those together, that still doesn't go away, does it? So it appears at this point that elimination's not going to work, right? Because nothing goes away. And this is where the beauty of elimination comes in. What I do is I think to myself, okay, well, wait a minute. You see these y's? They would have gone away if this would have been what in front of this y? A -2, right? If that would have been a -2 right there, they would have gone away, right? So I'm going to make a -2 appear here. And the way I'm going to do it is I'm going to multiply the entire equation by 2. So in other words, I'm going to rewrite this entire system of equations again, but I'm going to take this first equation, I'm put a 2 out in front of this, and I'm going to multiply a 2 through. Now, when I say multiply a 2, I mean a 2 times everything, both sides of the equation. So this 3x becomes what? 6x. And instead of minus y, it becomes minus 2y, right? And then equals, but instead of 12, it's going to become 2 times 12, 24. And then the other equation, you leave it alone. You don't touch it. Now, why are you allowed to do this? Why are you allowed to do this? Well, because we know that when you have an equation, you can always multiply both sides of the equation by any number and it doesn't change the equation. So this is a legal move to do this. And now, see, they're going to go away when we add down. Right? So let's add them down now. So now add down. This becomes 2x. This becomes 0 equals, and when we add over here, hey, this looks familiar, 31. So 2x equals 31. And then we could divide both sides by 2, and that would give us x is what? It was 15.5, right? Hey, same answer. It should be the same, better be the same answer, right? You shouldn't, that's the one beautiful thing about math is like, if you do things correctly, like we should get the same answer. Like you shouldn't get 2 different answers if you do it 2 different ways. All right, what am I going to do with that 15.5? Plug it into either equation. So would you rather plug 15.5 in right here for x or into the bottom one with the -4 in front? Probably the first one, but it doesn't matter, okay? It doesn't matter, it'll work in both. So I'm going to take this first equation, 3x minus y equals 12, and I'm going to replace the x with 15.5 minus y equals 12. And now I'm just going to solve this for y. So when we multiply that, we did that earlier, that was 46.5 minus y equals 12. We're trying to get y by itself. So subtract 46.5 on both sides. 12 take away 46.5 should leave you -34.5. But the left side is still negative y. See, because we had that minus here, we never got rid of it. So we have a negative on both sides, so we can multiply both sides by -1, and we're got the same answer. You can use the new equation as well. What's really cool about elimination is you can't screw it up. Once you get your answer, you can plug that answer into any equation you see. So if you want to plug it in here, go for it. If you want to plug it in here, go for it. Here, go for it. It should work. You should still get the same y no matter what. So what do y'all think? I've given you 2 examples. We've done them both with substitution and elimination. As of right now, do you have a preference or do you like elimination? I do too. I do too. Let's do another one. Okay. This will be kind of a hard one. Okay, here's your system. Let's go -3x plus 4y equals 24. And let's go 5x minus 3y equals 1. All right, there's the system. We want to solve it. what x and what y will satisfy both of these equations simultaneously. In other words, what's the intersection of these two lines? Well, think about substitution. Do you feel like solving this one or this one for y? They both kind of suck, right? Because this one has a 4 in front and this one has a -3. So if we do substitution, we're going to wind up having fractions. We're not going to be able to avoid it. Does that make sense to you? All right, but what about elimination? We do the other method, right? These added together doesn't give me 0, and these added together doesn't give me 0. I mean, it doesn't look like there's an easy way to fix it. Like here, the easy way to fix it was with the y's to make that a -2, right? And then it worked. But is there an easy way here to make either the x's or the y's go away? Anyone have an idea? Go ahead. You want to get rid of the x's? Okay. Okay, if I multiply the top one by 5, I know where you're going here, right? Then you're going to turn that -3x into a -15x. Okay, go ahead. Why don't we do a number on the top and a number on the bottom? That way we can get it to go away. So multiplying by 5 here gives me, it turns this into a -15x, but multiplying the bottom one by 3, right, will turn this bottom one into a +15x, and then they would cancel. That make sense? You sure? That's one way to do it, and that's the way I'm going to do it. But someone else could have done this. They could have said, I want to kill off the y's instead. And they say, okay, what is a number that is a multiple of both 3 and 4? Well, 12, right? So let's turn this into a 12y. So we'll multiply the top one by 3. And then let's turn the bottom one into a -12y. So we'll multiply the bottom one by 4. And that would also work. Notice there are two different ways. This way we're killing the x's off. This way we're killing the y's off. And it's up to you. You can do whichever way you want. So I'm not going to do this way. I'm going to stick with this one. So let's distribute the 5 through. Take a minute. You go ahead and try it real quick. Distribute the 5 through. Write down the equation, and let's make sure that we all have the correct equation written. The two new equations written out correctly. Is that what you have? What's wrong? It is 3. This is the most common mistake people make right here, is that they'll distribute the number through and they'll forget to do it on the other side, which I wanted to show you that. Okay, so this is a 3 down here, right? Because this 3 goes here and here and here, and then the 5 I did correctly. Okay, good. I was hoping you'll catch that. Now add down, right? When you add down, these two go away, right? Goes to nothing. Okay, how many y's do we have? 11. So plus 11 y's equals 123, right? 123. Unfortunately, we're going to have to divide by 11 now. And go ahead and get your calculator out for that, because that's not a nice number. And we might even have to round a few decimal places. 123 divided by 11. Yeah. 11.18.181818, like that, something like that. Let's just go 11.18. We know what y is. Be careful, right? We know what y is, so now we need to go get x. So any equation you want for x. Let's do the second equation. We haven't done that before. Let's grab the second equation and plug x into that one, just for fun. We could have picked the first one, but I'm gonna do that one. Just for fun, as if this is fun. Okay, 5x minus 3y equals 1, right? And I want to replace y, right? Not x. I want to replace the y with 11.18 equals 1. So 5x, that is going to be a minus. So I have to do 11.18 times 3. So minus 33.54 equals 1. What next? Add 33.54. So you should get 5x equals 34.54. And finally, divide by 5. X is, I'm getting about 6.9, 6.91. Close enough? I still like elimination on this one. I'm going to check this by graphing the two. I'll leave that up there. Graph this up here. Okay, so we have the first equation, minus 3x plus 4y equals 24. And then the other equation was 5x minus 3y equals 1. Here's the picture. You can see they obviously hit each other, and they hit at 6.909 and 11.182. So we got it. All right. You ready to solve that problem that we started class with? It may seem like we can't do it, but we can do it. All right. So let's go back to the problem that we started with. Here we go. You wish to mix a 5% acid solution with a 30% acid solution to get 2 gallons of 20% acid solution. How much of each should you mix? So before we do this, I'm going to move this to the end of the notes here. Before we do this, let's just agree on something. Let's say I had a container, okay, and it was full of some acid solution. What if I told you this was 50% acid solution? Let's just act like it is. And let's act like there were 10 gallons of this. Then you could imagine that half of this is acid, right? And the other half is basically water, right? So half of it would be water, half of it would be the acid. They're mixed together. So you've got 50% acid, 50% water. Make sense? So how many gallons of acid do I have? You have 5 gallons of acid and 5 gallons of water. That's simple enough to understand. From this, you would have 5 gallons of acid and 5 gallons of water. Okay, that's if it was 50-50. Let's try something else. What if I told you that it was 5%, okay, and it was 10 gallons total, 5% acid, right? Then how many gallons of acid do you have now? What is it? So 50-50 would have been 5 gallons, half. It's easy to do mentally, right? You had 10 gallons. So if it was 50%, half of 10, right? That's how you got 5. Here's a little bit, 5%, right? So the way you're doing this, okay, the mathematical way you're doing this is come back up to this. You know how we said 50% of this was acid? What you're doing is you're taking that number 50%, you're converting it to a decimal. That's 50% as a decimal, right? And you're multiplying it times how many gallons you have, 10. And if you do 0.5 times 10, that gives you the 5, and that's where this 5 is coming from. That's mathematically what's happening. So here, if I have 10 gallons and I have a 5% acid mixture, and I want to know how many gallons of acid are there, right? Then what you're going to do is you're going to take this percentage, right, as a decimal, which would be what? 0.05, right? And then multiply it times the number of gallons you have, which is 10, and that would give you what? 0.5, half a gallon, 0.5 gallons of acid. Let me do one more. What if you had a container that had 13 gallons in it? See, I'm going to start using numbers that aren't nice. 13 gallons in it. And let's say that this was an 18% acid mixture. How many gallons of acid are there? So what's the mathematical computation? Take this, turn it into 0.18, multiply that by 13, and you get 2.34 gallons of acid. Is this making sense to you? If I've got a 13-gallon container, and I'm telling you it's 18% acid mixture, then what you can conclude from that is that there are exactly 2.34 gallons of acid in there, and the rest of it's water. Could you tell me how much water is here? Yeah, just take 13, subtract that, and that's how much of it was water, right? Okay, we need all that kind of idea to do this now. Let's go back to the question. Here we go. So we want to know how much of each we should mix together, right? How much of each should we mix together? So let's assign variables here. I'm going to make this a little bit smaller. Okay, let's make that bigger. Let's let for this first one, let's let X be the gallons of 5% we're going to pour in, right? Because what we're going to do is we're going to pour these two together, right? We're going to pour them together, mix them into a container, and we want 2 gallons at the end, and that mixture at the end has to be 20% acid. So let's let X be the gallons of this we're going to mix, okay? And then let's let Y be the gallons of this. So Y is the gallons of the 30%. Now, is there anything you can tell me right now about the relationship between X and Y? Think about what we have to have at the end. How many gallons do we have to have at the end? We have to have 2 gallons, right? So however much of this I pour in, which I don't know how much it is, that's X. And then the Y together, right? That needs to be 2. Isn't that an equation? X plus Y must be 2. So that's my first equation. I know that X plus Y must be 2. Good. The next part's the tricky part. Let's talk about not the total amount of stuff in the containers. Let's talk about just the acid. Just the acid. How much acid is in this first one? In this first one, can you tell me the amount of acid that's in here? What were we just doing here? If I gave you something, right? If I gave you a percentage and I told you how many gallons, this is what you would do, right? If I gave you the percentage and I gave you the gallons, this is what you would do. Well, we kind of have that, right? Do we know the percentage of this one? Yes. Do we know how many gallons? No, but we could call it X, couldn't we? So what would be the computation to figure out the amount of acid there? Take the percentage, 0.05, right? And multiply it by the number of gallons over here, which is X, which I don't know, right? That's how much acid is in the first container when we mix it. Or I should say, this is how much acid is going to be contributed by that one when we pour it in. Now, what about the other one, the 30% one? How much acid is going to come from this one? 0.3, right? Times what? How many gallons of that are we pouring in? Why? We don't know, right? And then lastly, but almost most importantly, how much acid should be here at the end? Well, this we actually do know, don't we? Because it has to be a 20% mixture, 0.20, I'll put 0, times what? How many gallons are at the end? 2, right? So when I take this, right, that's the amount of acid coming from the first container when I pour it in, and I take this from the second container, pour it in, add them together, I should get this. That's my second equation. Let me write it down. I should have 0.05x plus 0.3y must equal, okay, this you can do on your calculator. What's 0.2 times 2? That should just be 0.4. Make sense? The first, look, the way that you should look at it is the first equation is just dealing strictly in how much stuff's there. So you're going to pour in some of it 5%, you're going to pour in some of the 30%, and at the end you should get 2 gallons. The second equation is talking about the concentrations of acid in each one. This is how much the 5% contributes, how much the 30% contributes, and at the end, this is the concentration we should have, or how much acid we should have. Kind of make sense? Let me write down our system. Our system is x plus y equals 2, and 0.05x plus 0.3y must equal 0.4. Okay, we have not done a system like this before, have we? Not with these decimals, have we? So decimals kind of make things harder. So what I'm going to do just to start this out is I'm going to take this last equation and I'm going to multiply everything here by 100. Now, why am I doing that? When you multiply by 100, what happens to the decimal? Moves to the right by 2 places. So what I'm trying to do is get this to become a 5. So you could even do this using that elimination thing where you put the 100 out here. Let's rewrite the system. X plus y equals 2. And now I'm going to have 5x. How many y's are we going to have? 30, because this decimal point moves 2 places to the right. So we get plus 30y equals, and then the last one, 40. There you go. That is a nice system right there. How would you like to solve that? Elimination? You would go -5 on the top. Does that sound good to everyone? Let's go -5 on the top because that'll kill off the x's. Multiply the top equation by -5. That has the effect of turning this into -5x minus 5y equals -10. And then the other equation we're not touching. Add down. The x's go away. Plus, what, 25 y's are still here? And then 30. Divide both sides by 25 to get your y. 1 point something. Oops, ooh. 1.2. So we know what y is, right? Y is 1.2. How are we going to get x? Take this answer and plug it into any equation. Which one looks the best to you? Yeah, this x plus 2, this x plus y is 2. That's a clean equation. Let's plug into that one. So if I take that equation from up there, x plus y is 2, and replace y with 1.2, we get x is 0.8. And we've answered the question. This is gallons, and this is gallons. So if you've got a container that has 5% acid in it, and another container that has 30% acid in it, and you want to mix them together to have 2 gallons of 20% acid, you're going to do 0.8 gallons of the 5% mixture, right? You're going to do 0.8 gallons of this, and you're going to do 1.2 gallons of this. At the end, you'll have 2 gallons, and it'll be 20% acid. That's it. Okay, so we are out of time. What I'll do, I'm going to do what I did last time. I'll send you some problems to work on for systems of equations. I realize that it's Easter weekend, so I'll send them out probably tomorrow, today or tomorrow. And you don't have to have those ready to turn in when we come back on Tuesday, but let's say Thursday for sure. Okay. All right, everybody, have a great weekend.